Training, testing, and unseen data flow in NeuroGov Plus, Advanced AI. The architecture illustrated in this governed intelligence framework represents one of the most important foundations of the evolving NeuroGov Plus, Advanced AI, ecosystem developed around the 3D, 10D AI DNN Engine, Cognitive Cube, Analyzer 1.0, and the IGA 2026 Governed Enterprise Intelligence Architecture. The framework demonstrates how governed AI systems must move beyond traditional prediction-only models towards structured intelligence engineering where training, testing, governance validation, and unseen data assurance operate together as a controlled enterprise intelligence lifecycle. The first stage training data represents the learning foundation of the governed AI brain. In this stage, enterprise datasets from ERP systems, IoT devices, operational records, financial systems, healthcare systems, educational systems, manufacturing operations, governance repositories, and enterprise documents are transformed into structured intelligence-ready datasets. The objective is not merely machine learning but multidimensional governed intelligence preparation using the 3D, 10D cognitive cube architecture. During this stage, dimensional mapping, feature engineering, normalization, labeling, classification, and governance tagging are performed to create structured enterprise intelligence memory. Within the 3D, 10D AI DNN Engine, Cognitive Cube, the training stage becomes significantly more advanced than conventional AI systems because intelligence is generated simultaneously across multiple dimensions. Operational intelligence, predictive intelligence, sustainability intelligence, governance intelligence, explainability intelligence, ethical intelligence, strategic intelligence, and policy-aware intelligence are calculated together. This multidimensional approach allows NeuroGov Plus to evolve from a simple AI prediction environment into a governed enterprise intelligence ecosystem capable of supporting complex board-level decision support systems. The second stage testing data functions as the enterprise validation and trust engineering layer. In traditional AI systems, testing is often focused mainly on prediction accuracy. However, inside NeuroGov Plus and IGA 2026, testing also validates governance stability, policy compliance, explainability reliability, threshold consistency, RMSE stability, and controlled deployment readiness. The system performs governance-oriented evaluation to determine whether generated intelligence can safely move toward enterprise execution environments. The testing phase is critically connected with Analyzer 1.0, which acts as the governance brain of the architecture. Analyzer 1.0 calculates KPI, TSI, OSI, RMSE, trust scores, drift stability, and governance risk before allowing enterprise authorization. This separates intelligence generation from authority control. AI may generate patterns, predictions, and recommendations, but governance layers validate whether those recommendations satisfy enterprise thresholds, policies, ethics, sustainability requirements, operational tolerances, and compliance conditions before execution approval. The third stage, unseen data, represents one of the most powerful aspects of governed intelligence systems. Unseen data refers to real-world operational data entering the system after training and testing have already been completed. This includes new transactions, new customer behavior, new operational conditions, emerging risks, new regulations, new manufacturing events, healthcare incidents, financial market fluctuations, and unexpected enterprise patterns. The unseen data layer validates whether the governed AI brain can safely operate under real enterprise uncertainty. Inside the IGA 2026 architecture, unseen data is not treated as uncontrolled autonomous AI execution. Instead, it enters the inform rightward arrow govern rightward arrow assure life cycle. In the inform layer, the AI engine generates intelligence. In the govern layer, Analyzer 1.0 and the policy engine validate the intelligence against governance rules, thresholds, ethics, sustainability expectations, and organizational policies. In the assure layer, auditability, accountability, evidence management, and enterprise trust validation are recorded for assurance and regulatory visibility. This governed life cycle establishes one of the most important distinctions between traditional AI systems and NeuroGov Plus, advanced AI. Traditional AI systems often focus primarily on prediction generation, whereas NeuroGov Plus focuses on governed enterprise execution. The architecture ensures that intelligence is explainable, traceable, policy-driven, auditable, stable, and aligned with enterprise governance requirements before operational approval is granted. This creates controlled enterprise intelligence rather than uncontrolled autonomous intelligence. Another major strength of this architecture is scalability across domains. The same governed intelligence architecture can operate across healthcare, manufacturing, finance, education, logistics, ESG governance, smart cities, public administration, energy systems, and enterprise governance environments. Only the domain packs, policies, thresholds, and operational datasets change, while the governance architecture, analyzer framework, cognitive cube intelligence generation, and IGA 2026 assurance flow remain constant. This reflects the strategic principle of one engine rightward arrow and domains. The architecture also demonstrates the future direction of enterprise AI engineering. Instead of organizations building isolated AI prediction systems for each department, NeuroGov Plus introduces the concept of a centralized governed intelligence architecture where policy-aware intelligence generation, governance validation, runtime control, audit assurance, and enterprise DSS operate together as a unified enterprise intelligence operating environment. This significantly improves trust, explainability, governance visibility, compliance readiness, and enterprise scalability. Summary: the training, testing, and unseen data architecture within NeuroGov Plus, advanced AI, demonstrates how governed enterprise intelligence systems must evolve beyond traditional AI prediction models. By integrating the 3D, 10D AI DNN Engine, Cognitive Cube, Analyzer 1.0, the Policy Engine, and the IGA 2026 Inform Rightward Arrow Govern Rightward Arrow Assure architecture, the system transforms raw enterprise data into governed, explainable, auditable, and policy-controlled decision intelligence. The architecture ensures that intelligence is not only generated but also governed, validated, and assured before enterprise execution. Power Summary: NeuroGov Plus, Advanced AI, represents a shift from predictive AI toward governed enterprise intelligence engineering. The 3D, 10D AI DNN engine generates multidimensional intelligence, Analyzer 1.0 validates governance and trust stability, the Policy Engine enforces enterprise control, and IGA 2026 assures auditability and accountability. Training builds intelligence memory, testing validates governance stability, and unseen data proves real-world enterprise readiness. Together, they establish a new generation of governed AI architecture where AI thinks, governance decides, and assure proves. Domains for which NeuroGov Plus, Advanced AI, has been tested. The NeuroGov Plus, Advanced AI, ecosystem developed around the 3D, 10D AI DNN engine, Cognitive Cube, Analyzer 1.0, and the IGA 2026 Governed Enterprise Intelligence Architecture has been conceptually engineered, prototyped, governance validated, and cockpit tested across multiple enterprise and institutional domains. Tested/validated domains: manufacturing governance, production planning and control, PPC, supply chain and logistics, healthcare governance, hospital management information systems, HMIS, blood bank governance systems, education governance, ISO 21001 education systems, NEP 2020 governance models, student performance intelligence, finance governance, CFO level DSS architecture, audit and compliance systems, KPI rightward arrow TSI rightward arrow OSI governance systems, RMSE stability and release gate validation, ESG and sustainability governance, governance risk and compliance, GRC, enterprise DSS and board level analytics. Smart governance systems. Smart nation governance architecture. Enterprise resource planning, ERP, governance. Oracle/SAP integration governance. AI governance and explainability systems. Controlled AGI governance. Policy-driven runtime governance. Enterprise intelligence lifecycle governance. Data governance and governance analytics. Predictive enterprise intelligence. Multi-domain governance cockpits. Scenario AVSB governance simulation. What-if analysis governance. Enterprise audit assurance systems. Governance engineering architectures. Runtime policy orchestration. Governed AI operating environments. Enterprise visibility and strategic intelligence systems. Decision assurance frameworks. Public intelligence and national governance systems. Research and mentorship governance systems. Multi-domain enterprise intelligence cockpits. Strategic observation. The testing across these domains demonstrates that NeuroGov Plus is not designed as a single domain AI solution, but as a governed enterprise intelligence architecture capable of scaling across industries while preserving the same governance core. Inform rightward arrow, govern rightward arrow, assure. Analyzer 1.0 governance validation. KPI rightward arrow, TSI rightward arrow, OSI decision framework. Policy-driven execution control. RMSE stability validation. Auditability and enterprise assurance. This validates the architectural principle. One engine rightward arrow and domains. Where the governance brain, analyzer framework, runtime policy architecture, and governed intelligence lifecycle remain constant while only domain packs, thresholds, policies, enterprise workflows, and operational data sets change across industries. Enterprise significance. The successful cockpit testing and governance simulation across these domains strongly indicates that NeuroGov Plus, advanced AI, is evolving toward a governed enterprise intelligence platform. Governance operating architecture. Multi-domain decision intelligence system. Enterprise governance runtime. Post-LLM governed AI ecosystem. Rather than a traditional isolated AI prediction platform. About Dr. Pradeep K. Suri. Dr. Pradeep K. Suri is the inventor and architect of the 3D, 10D AI DNN Engine, Cognitive Cube, Analyzer 1.0, NeuroGov Plus, Advanced AI, and the IGA 2026 Governed Intelligence Architecture. His work focuses on transforming AI from isolated predictive systems into governed enterprise intelligence ecosystems capable of explainability, auditability, policy enforcement, sustainability governance, and enterprise-scale decision assurance. His professional journey spans manufacturing, ERP integration, healthcare systems, enterprise consulting, Oracle/SAP integration, cloud architectures, governance engineering, and multi-domain enterprise intelligence systems. Over decades of industry and governance experience, he evolved the concept of multidimensional governed intelligence where AI-generated intelligence is separated from governance authority through Analyzer 1.0 and policy engine control. Through NeuroGov Plus and IGA 2026, the author work positions governed intelligence as the next evolution beyond traditional AI and LLM-centric systems. His architecture establishes a framework where enterprise intelligence is explainable, policy-aware, traceable, auditable, and aligned with organizational trust, ethics, governance, sustainability, and operational accountability requirements.